In this video, we'll cover ions. Ions are atom or group of atoms with a net positive or negative charge. For example, something with Na, like sodium, and then it has a positive charge like this, plus. Now, you might notice it's just a positive, rather there's no 1 or 2. Scientists are quite lazy. We don't like to write 1 for some reason, but this is same thing as an Na plus 1, or we can say Na plus 1 plus is also a possibility, okay? Plus 1, 1 plus. You might see that interchangeably. So these are all ways to write a positive charge. Or you can write something like this, a group of atoms. So Na, there is a group of atoms called NO3, and then there is a minus in the N, okay, like a negative, 1 negative. Or you can write it as NO3, and then, or you might have NO3, and then it will have minus 1, something like this. So that's a group of atoms with the negative charge, and this has to be a negative 1. Let's talk about positively charged ions, and they are cations, okay? So cations are something with a positive charge. Take, for example, lithium. Lithium in your periodic table, you'll see that it's under number 3. It's saying that there are 3 protons are in the nucleus, and so if it's a neutral atom, there are 3 electrons. 3 positives and the 3 negatives, they cancel each other out. However, if you look over here, if 1 electron is lost, and there's only 2 electrons, and there is 3 of the positive, where over here there's only 2 of the negative, the overall net would be positive 1. So therefore, lithium can be written as Li, and there is a plus sign. If I were to lose another electrons, then there will be 3 protons and 1 electrons. So one of the proton will cancel out with the with one of the electrons, and then you'll be left with 2 positives. So that would be a lithium 2 plus. Can you get rid of all of the electrons? Sure, if you get rid of all of the electrons and only 3 protons remain, that gives a charge of plus 3. Let's talk about anion, or a negatively charged atom. So here, chlorine, can you find chlorine on the periodic table? In the periodic table, chlorine is number 17, which means that there are 17 protons in here. If you count all of these electrons that are around it, this chlorine has 17 electrons. So 17 protons, 17 electrons, so therefore there is going to be a neutral charged element, just Cl. Notice here, one of the sodium will donate its electron to the chlorine. Now chlorine has 18 electrons and 17 protons. What does that mean? Well, that means that there's more electrons, 1 more electron than the protons, giving it a negative 1 charge. If it has 19 electrons, yes, the chlorine would be negatively 2 charged. Nevertheless, the whole point is to introduce this anion, and anion is a negatively charged atom. Based on this, let's go over learning check. List the number of protons and electrons in the following ion. Remember, proton number never changes. try this and come back. Coming back from the pause. So fluorine has 9 protons and it has 10 electrons because this is a fluorine anion with the charge of -1. There's one more of the negatives higher than the protons. Calcium, there are 9 protons. Oh, I apologize. Calcium has 20 protons. And electrons, there's 18 of them. And that's because 20 more, there's 2 more of the positive than the electrons would be 18 of the negatives. Let's do another one. Here, I'll do this one with you. If you want to try pausing and then coming back, you can do so. Silver in the periodic table is 47. So therefore, the number of proton is 47. Now, how many neutrons? Remember, the neutron is this mass number minus the proton. So you can get out your calculator and then you can calculate 109 minus the 47. That should give you 62 neutrons. What about electrons? So notice here there is positively charged, +1. So therefore, electron is 46. There's 47 of the positives and 46 of the negatives, so that the overall net charge of the ion would be +1. Lastly, I like to cover the periodic table charge trend. You notice that we have negatively charged and positively charged rows here. What this represents is that there is a tendency for the rows of these rows to be positively 1 charged element. The next one, +2, skip on over, and then to +3. Then skip 1 row, -3, -2, and -1. That's the trend that it typically has of these elements. They don't like to stay neutral, but rather they like to obtain these charges when they're by themselves. So knowing that, so we'll go ahead and try the learning check here. It says state charge each element typically gets as an ion. Does the charge indicate that they have lost or gained electrons? So let's try magnesium. Magnesium is in that second row as shown above right here, +2, right? Magnesium. So they have +2. +2 is their typical charge as they become an ion. What does that mean? Did they gain or lose electron? That means that they have lost 2 of the electrons, so that 2 more of the positive of the proton overpowers the rest of the electrons. So try the next one and come back. And here is the key.